This next topic is just included here because it is closely related to the topic on parameterization of the complex line integral. At the same time, it is connected to the idea of solving for the integral of a certain function. This time, we are going to talk about the parameterization of the real line integral given as the integral of p of xy dx plus q of xy dy along the path which is identified as c. Take note that both functions p of xy and q of xy are functions with components of x or y and a combination of both. Now, if we're going to talk about parameterization of real line integral, it is similar to the parameterization of the complex line integral. It's just that at this moment, we're going to focus into some functions which relate to real numbers instead of some concepts or items or numbers which are complex in nature. Of course, we're going to relate them later on to the complex analysis, but these is also very important for this playlist so that the idea of parameterization for complex line integral at the same time its implications later on are actually duly established. So let's talk about this one here. So our function or the integral, okay, the integral of your p of xy dx plus q of xy dy along our certain path c. We of course need a certain function which is a parameter of variable t. Same with the idea of the integral of your f of z dz along your path c, which is identified as the integral of your f of z of t, previously discussed. Okay, this is actually its component, right, from a to b. This is for the complex line integral. It is for the real line integral. We are also going to provide the parameters need to be used for specific types of functions, but generally this is how it is done. Take note that our given z complex number is actually expressed as x plus iy. So if we have here z of t, this also stands for x of t plus I of y of t, right? Just for the component itself. And take note that in this case, our x stands for, okay, let's make it equality, stands for x of t now, and our y stands for y of t. Similar thing, just for the purpose of discussion, our t is between a and b endpoints of your curve, in this case for your real line integral. Now, to parameterize the real line integral, we need to make sure that we could actually express the integral of this in a form of this form here. We have our functions, this would be our x and y, but we need the first derivatives for both of them. Okay, so say for example, okay, so we have here our x is identified as x of t, therefore its first derivative is x prime of t. Similarly, your y is y of t, so its first derivative is of course expressed as y prime of t. So our component here for our integral for our p of x and y dy, it's dx plus q of xy dy, and its parameterization is equivalent to this form, the integral from a to b of your function p of x of t, just like again this form here, but since it is a combination of x and y component, you have y of t, that's for the function, times the derivative of your dx. Dx is actually expressed in this manner, so you have x prime of t plus, okay, let me move it here to place the complete form, plus for your q of your x of t and y of t, and then your dy, which is expressed as y prime of t. So you have here times y prime of t. These are all to be integrated with respect to t. Okay, so this is now its final form, which is similar to this, but since our function here are a combination of two different forms, okay, so we can actually write it this manner, right? Just like that. Okay. So this is when we also have two different forms here, similar to the previously discussed parameterization for our complex functions, where we have the function itself and then to be multiplied with a certain derivative pertaining to the identified real line integral here. So this is the formula for the parameterization of the line integral, but the component of your x of t, y of t will be dependent on whatever would be type of path, at the same time the functions which you will be using later on. So in the next few videos, we're going to provide here formulas for the parameterization of the path regardless of, depending on the type of the path, whether it's a straight line between 2 points, horizontal line, vertical line, or even the curve. We will have that in a separate video. Thank you very much for watching.